11 minutes. That's how long the entire company was down. No checkout, no login, no API. Every single request timing out. And the cause wasn't a bad deploy. It wasn't a bad actor. It wasn't the cloud provider. It was one query. One query that had been perfectly fine for 2 years. This is the story of how a missing database index took down production and why the query itself was never really the problem. I'll walk you through the exact dashboards I looked at, the wrong conclusion I jumped to first, and the two-line fix. If you own anything with a database behind it, this will save you an outage. Let's go. It starts with latency, not errors. Latency. P99 response time goes from 80 milliseconds to 4 seconds in about 90 seconds. Then errors start. 503, then 504, then everything. The app servers are healthy, CPU is fine, memory is fine, but every request is stuck waiting on something. And when every request is stuck waiting, there's usually exactly one thing they're all waiting on. First instinct, scale up. More pods, more capacity, ride it out. I bumped the deployment from 6 replicas to 18, and the outage gets worse, faster, because every new app server opens its own pool of database connections, and the database was already the bottleneck. I didn't add capacity, I added pressure. Scaling up a database-bound outage is like adding lanes to a highway that ends in a parking lot. So I stopped guessing and opened the database. PG stat activity, one query, 240 copies of it, all in active state, all running for 8, 9, 12 seconds each. Max connections is 250. The pool is full. Everything else in the entire system is queued behind it. That's the real shape of this outage. It's not a crash, it's a traffic jam. The query is boring. Select star from orders where customer ID equals something and status equals pending. Order by created at DESC, limit 20. It's the order history endpoint. It's been in production for 2 years. I run explain analyze on it. Sequential scan on orders. 14 million rows. Every call. And it had always been a sequential scan, back when orders had 40,000 rows, and the scan took 9 milliseconds and nobody noticed. So why tonight? Two things collided. One, the orders table crossed a size threshold where the scan finally exceeded the connection checkout time. And two, that same evening, marketing sent a push notification to 800,000 users. Everyone opened the app. Everyone hit order history at the same time. The query didn't get slower. It got called more. And a slow query only becomes an outage when concurrency multiplies it. Here's the magic fix. Create index concurrently on orders, customer ID and status, and create it at descending. Composite in that exact order. Equality columns first, then the sort column. Concurrently, so it builds without locking writes on a table that's already on fire. 4 minutes to build. Explain analyze again. Index scan. 14 million rows down to 20. 8.2 seconds down to 1.1 milliseconds. Connections drain. Latency drops off a cliff. We're back. Here's the lesson, and it's not at an index. Every performance bug in production is really a concurrency bug wearing a costume. A query that takes 8 seconds is a curiosity. A query that takes 8 seconds, called 200 times a second, with a connection pool of 250, is a total outage. Latency times concurrency equals saturation. If you only measure query time, you will never see the outage coming. The mental model I use now. 1. Latency before errors means saturation, not crashes. Go look at the shared resource, not the app. 2. Never scale app servers during a database incident. You're adding customers to a restaurant with one chef. 3. Explain analyze everything that runs in a request path at production row counts, not at your laptop's row counts. 4. Every index you don't have is a bet that the table stays small. Tables never stay small. What I do differently now, auto-explain is enabled in production, logging any query over 500 milliseconds. PG stat statements is on a dashboard sorted by total time, not mean time, because the query that kills you is the fastish one called a million times. Statement timeout is set, so a runaway query dies instead of holding a connection hostage. And there's a connection pooler in front of the database, so a stampede queues at the pooler instead of exhausting Postgres itself. Before you ship any endpoint that touches a table, 3 questions. What does explain analyze say at 10 million rows? What happens if this endpoint is called 1,000 times in 1 second? And what holds the connection while this runs? If you can answer those 3, you will not be the person on the call at 11:40 at night explaining what a sequential scan is. 11 minutes down, 1 index, 2 years of warning signs that nobody was measuring. The bug was never the query. The bug was that we had no idea what our own database was doing under load. Latency times concurrency. Measure the shared resource. Index before you need it. That's the whole video. If this saved you a bad night, subscribe. I'm doing one of these every week from real production incidents. Drop the word index in the comments if you want the next one. The caching layer that served the wrong user's data to 40,000 people. See you in the next one.